participants as well. Basically, we have to go over the basic concepts on how we schedule irrigation in almonds in California. Before we move on to the second section, maybe 1 hour into the presentation, we can stop for question answer sessions. One thing that I would like to tell all the participants is this is our first interaction of several interactions, this month and next month. So what I think would be best is that if we have a detailed question and answer session today at the end of the presentation, so that there are things that you might have new questions that you came up with, and then in subsequent meetings, in subsequent presentations, I can bring in some research-based answers to those questions as well. Okay, so let's get started. Before I get into my presentation, does anyone have any question? Okay, all right, so let's get started. This is the outline of my presentation. These are not discussed necessarily in this same order. So first, we will go over the basic concepts in irrigation scheduling, how we calculate water usage, how we go about evapotranspiration-based irrigation scheduling. We'll talk about the wind affecting evapotranspiration. I've seen that there are a lot of places in Georgia that have high winds. So how wind affects evapotranspiration. We'll talk about irrigation management under drought, regulated deficit irrigation. We'll talk about post-harvest irrigation. I'll also talk a little bit about almond production function studies done here in California, and then water use efficiency of different rootstocks. We'll talk in detail about effects of over irrigation, and then a little bit about irrigation technology. Okay, so this is a slide putting together a lot of information that I calculated based on the California almond water demands on a per season basis. When we can break it up on a daily basis when we calculate daily evapotranspiration. Okay, in California, typically we have seen this water demand for almonds put at 52 acre inches, which seems higher in today's scenarios because a lot of orchards, they don't irrigate that much. A lot of orchards don't have that water. And then the almond production function studies showed us that we really don't need 100% matching to that 52 acre inches. Now, if I have to convert acre inches into megaliters per hectare, here are some calculations that I would do. I know in Georgia, there's metric system, and that 52 acre inches translates to about 13 megaliters per year per hectare. Okay, so the basic calculation is basically 1 acre feet is about 1 acre feet per acre is about 3 megaliters per hectare. Okay, but most of the orchards don't irrigate about 13 megaliters. They just irrigate about 10 to 12 megaliters. And in California, that is made possible with a couple of different technologies and a couple of different things, parts of the system. Number one is the efficient irrigation systems, drip irrigation system, micro sprinklers that increase the irrigation distribution uniformity, also increase the irrigation efficiency. We will talk about those terms later. Also, in California, we do regulator deficit irrigation. We'll talk about that in here in a moment. Regulator deficit irrigation is basically applying less amount of water during some of the crop growth stages. And then a big part of this irrigation strategy or irrigation scheduling is basically matching the soil type and evapotranspiration demand and doing the irrigation scheduling in a very fine-tuned and proper way so that we avoid over irrigation, but we also avoid water stress, too much water stress. This is one example calculation that I picked one day in June. And the evapotranspiration, I've experienced and I've seen in both in Georgia, particularly in Kakheti region, the daily evapotranspiration during the peak months of June and July, it's about the same in the Central Valley of California versus Kakheti region of Georgia. So typically in a hot day in June, the evapotranspiration is 0.32 inches, for example. And then there's crop coefficient for almonds. The newer crop coefficients came at 1.15, which is higher than what used to be the common knowledge about 10, 20 years ago. One of the almond production function studies that I was reading recently, last week, it mentioned that over the last several years, in fact, several decades, the evapotranspiration calculations for the almond orchards have increased. It could be due to, a newer research done on crop coefficients, but also it could be due to the effects of climate change. In the recent years, we have much more hotter years. We have a lot of days with low relative humidity. So low relative humidity, high temperature increases vapor pressure deficit, and that increases evapotranspiration. So there are a lot of factors. However, the same production function study that I was reading from the University of California here, it said that over the last several years, the yield for the almonds, California almonds, for the same amount of water has increased multiple times. So the calculations were done in the research paper, but the main idea is even when the evapotranspiration demand has increased, the yield is increased much higher so that it actually compensates for the water used. And the bottom line was, the take-home message was that we have increased our water use efficiency to higher levels than what it used to be 10, 20 years ago. So that was a justification of applying the amounts of water that the almond trees take because we are getting higher yields. And in that, not only these components of the irrigation system are effective, but also the rootstocks, newer rootstocks and newer cultivars, different orchard system design, genetics, a lot of things play a role. Okay, so just a little bit about what is evapotranspiration. I have mentioned evapotranspiration a couple of times. Some of you already, I checked the names of the participants and there were some familiar names from last year. So you have gone through these concepts, but it's always good to reinforce the concepts. Evapotranspiration is the sum total of transpiration plus evaporation. There are two different processes, and evaporation is a physical process, basically water evaporating from any surface or any body of water through simple radiation, heat of sun. And then transpiration is a physiological process that happens from the leaves of the trees. Underside of the leaves have stomata, and transpiration is a part of the photosynthetic process. The trees lose water drop by drop, molecule by molecule, and it evaporates, it basically dissipates into the atmosphere. So that is transpiration. The sum total of transpiration plus evaporation is evapotranspiration. And that is basically the total water loss from an orchard system. Whatever water you apply, either it has to go up in the air through transpiration, or it can directly evaporate from the surface. And then obviously the main fate of that water, the main goal of that water is that a lot of water is absorbed inside the tree for the cellular function. So those are major components. The other undesirable component is a lot of water actually goes down the root system, percolates in the soil down below the root zone, and that is lost to groundwater. So those are only 3 or 4 ways that the water actually ends up after we apply to the orchard. Okay, so now how do you determine the total water demand of the trees? We calculate evapotranspiration. So evapotranspiration is basically calculated based on 2 major components. One is the evapotranspiration from a reference crop like grass-based ecosystem. That part of the equation for evapotranspiration is supplied by the weather stations usually. And another part of that equation is the crop coefficient. I will go into the details of that in the next slide when it comes. Evapotranspiration is affected by environmental conditions. We have seen that hot conditions, high temperature, lower humidity, solar radiation, wind speed. The wind speed, higher the wind speed is, higher would be the water loss from the tree, in terms of transpiration especially. And then presence of cover crop. In California, we have these days, because we want to improve our soil health, we plant a lot of cover crops in the middle. Whenever there is a cover crop, that means there are leaves on the ground as well, in addition to the trees. So the cover crops take up a lot of water demand. This is a list of crop factors and management factors in evapotranspiration. So you can see that there are a lot of different factors that affect the evapotranspiration. Obviously the crop, what kind of crop you're growing, what kind of cultivar. We have different rootstocks, different cultivars, varieties having different evapotranspiration demands. Then phenology, of course, the stage of development throughout the season, from leafing out to all the way to post-harvest, there are different stages. Height of the tree, canopy size, planting design, rooting depth and profile characteristics. Soil is a big component of the evapotranspiration demand, and then presence of cover crops or not. There are things that we cannot change, and those are pretty much the crop factors. So sometimes there are factors that we can change through the management, and that basically is in management factors like diseases, insects, fertility program, salinity, or the irrigation system design, planting design. So we have some control over these that we can actually change through our management practices. So those are the management factors. Once we plant the crop, once we select the cultivar, we cannot change. The soil profile characteristics, we cannot probably change. So this is a general trend of the water use for the almond trees. from right after bloom through the leaf out stages all the way to the full canopy growth during the summer months. And then going into fall, the evapotranspiration decreases, and that decreases the water use for the trees. Evapotranspiration also changes with age. The almond tree canopy size increases from the first year to fully mature trees when the trees get to their full potential by year 7 or 8, depending on the variety, depending on the other growing conditions. After the tree has attained their full mature size, the tree canopies do not change much over the rest of the life. Annual pruning, we do annual pruning, but we get similar growth every season. So the first 6 or 7 years, right from the planting all the way to attaining mature size, that's when evapotranspiration increases considerably every season. So for young trees, we have to calculate the evapotranspiration differently. In California, we have a couple of different research-based tools, and there is one simple Excel worksheet developed by the University of California here, where we have the tools to calculate the evapotranspiration for the region, for each region that you work with. And then in that tool, we have calculated how much percentage of that total mature size would need to be applied in year 1, how much percentage in year 2, year 3, year 4, all the way to full maturity. So that helps when a grower has 2-year-old trees, the canopy sizes are small, they calculate the evapotranspiration demands for mature trees, and then they work out the percentage. For example, a 2-year-old tree takes only 20% water of a fully mature tree. So that's how they adjust their calculations for young trees. How wind affects evapotranspiration. I have seen a lot of scenarios in Georgia last year where there was strong high winds, and those winds, particularly during the summer months, the winds are dry, of course. So they increase the evapotranspiration demands a lot. And that is a factor. There are complicated calculations to do that, because a lot of different components are built into those models that the weather stations use. So for a particular region, for a particular high wind scenario on a particular day, the evapotranspiration calculation would be done by a weather station, and those calculations would be higher than a non-windy day. The current environmental conditions other than wind, temperature, humidity, solar radiation, all of them affect, okay? And they affect both evaporation as well as transpiration. With wind, because we have increased air movement, we have increased transpiration rate. That is because when wind is moving around, the air closer to the leaf is more saturated because it has water vapors in that air escaping from the leaf stomata. But when the wind is moving fast, that saturated air is shifted away and it is quickly replaced by drier airs coming from outside, okay? So that actually creates a vapor pressure gradient, means that the relative humidity is much more lower just outside the leaf. So there is a deficit in the vapor pressure inside the leaf and outside the leaf. So that actually increases transpiration a lot. Wind also creates a lot of drifting of sprinklers. So when there is a sprinkler irrigation system, wind actually makes the water fly away. So it reduces the irrigation distribution uniformity. And we'll talk about the distribution uniformity also later today. So distribution uniformity also plays a great role in getting the uniform water applied to the root zone. So wind has a lot of serious effects on the evapotranspiration and overall tree water demands. Okay, this is a chart from here in California. This is basically a non-windy scenario, basically light wind, and the pink dots are dry and strong winds. So there is a significant difference as the season progresses. The differences actually start getting higher and higher. So let's get into irrigation scheduling. For irrigation scheduling, proper irrigation scheduling, what you need to know. You need to know your system's output, how much water you can apply every hour to your orchard. You have to know your soil type. That is a really important factor. How much water your soil can hold. Every type of soil, every texture of soil has different water holding capacity. And that is usually a given. There are a lot of different research papers and a lot of different resources to find that out. Also, you need to know your system's efficiency. And whatever system you have, if you have flood irrigation or if you have drip or sprinkler irrigation system, the efficiency, the system efficiency is basically it's basically a function of how much water you are applying through the system in the beginning and how much water is actually getting at the end of the system, getting to the root zone where you intend to apply it. And obviously the flood irrigation systems are much more inefficient because we apply a lot of water and only just a little water gets to the root zones and a lot of water goes to the underground deep percolation. Drip and sprinkler irrigation systems usually have 90 to 95% system efficiency. And then know your trees' daily water needs. And the trees' daily water needs would be calculated based on the evapotranspiration. I'm walking you through this system because I already checked for Georgia. There are evapotranspiration data available for different regions. There are some websites that can actually give you the information that you need to start with. Oh, sorry, it goes back to previous slide. Okay, so we'll come to this slide, the excess moisture thing particularly later. But just to give you an overview, we have to walk a fine line because the almond trees, if they get drought stressed, which we have a lot of drought stress these days in California, this year was a drought year. And I'm sure, I've seen in Georgia, there were a couple of orchards that we visited that they did not have enough water or they had poor quality water. So the drought stress really affects your yield, your kernel quality. The kernel shrivel, the nut size is low. It can cause wilting. Drought stress can cause defoliation, and the shoot growth inhibition leads to reduced yields, not only this year, but also the next year. Excess moisture, I have some detailed slides on how excess moisture affects the health of the orchard and the health of the trees. So we will go to those details later. So stepping back to from the evapotranspiration based calculations, I just wanted to go through some different methods that you can use to determine water needs. We have soil-based methods, and the age-old method is visual or touch method. Or using soil moisture probes to see how much water is available inside your soil, and you can just guesstimate how much water you want to apply. And then the weather-based methods, the evapotranspiration that we have been talking about. Then there are plant-based methods. I would not say that this is actually a fully blown method by itself, but plant-based methods would be the plant-based monitoring tools like pressure chamber or other sap flow sensors. Those tools basically guide us on when to start irrigating or when the tree is going to the water stress situation. So these tools are really not enough to calculate how much water you need to apply. So you need to use these plant-based methods or plant-based tools in addition to using the soil moisture sensors or weather-based methods to actually figure out how much water you need to use or you need to apply. Everybody who is in farming is probably aware of this method, visual touch method, making a ball or a ribbon. And you cannot take this for granted, although it's a common knowledge, but this will vary with the conditions of your soil. Okay, so excuse me. I have listed the variability in this method based on the variability of the soil type or soil conditions. And you can see that if you have sandy soil and low moisture means when the soil is dry, it will fall apart and crumbles. Okay. Then clay loam to clay soils, fine textured soils, they're plastic and sticky. It forms a long ribbon. So depending on your soil, you have to know your soil year after year or on a daily basis, week after week. And then you can have a feel of when you think your soil has too little water. This is, of course, a crude method that is not preferred these days because we have technology. So the other thing to know is to know your water application rate of the system. Whatever system you have, you need to know how much water you can apply in 1 hour or in 1 day. Okay. For flood irrigation system, you can calculate that water application rate based on your pump output. For drip and micro irrigation system, the output or system application rate will be written in your design documents. The company will know the output of your system, both at the pump level and the output of your system at the emitter level that will already have the system efficiency calculated within itself. One fan jet approximately applies about 38 liters of water per hour. That's the common design, but there are so many different variations of these systems. Common drip emitter output is about 2 liters per hour per emitter. So it depends on your irrigation system design, how many emitters each tree gets, if you have a single line drip or a double line drip irrigation system. So a lot of variables. So once you have your irrigation system in place, that is a fixed, that's a given number. You can basically have that in your notes and then work from there. And all you need to do is just keep the system working, keep the system flushed, system maintenance every year, so that the system efficiency remains improved and distribution uniformity remains improved. And you can calculate, you can use these numbers year after year. Now, you also know that how many trees you have per hectare, and then what is the tree to tree spacing, and how many drip emitters you have for each tree. So all these things you already have in your notes. For flood and furrow irrigation systems, if we step back, we simply calculate how much water the trees need daily based on the evapotranspiration calculations. And you apply that much water to the trees after factoring in the system losses. That is really important. If you just apply your tree's daily needs and apply that much water, of course, the system efficiency is really low in flood and furrow irrigation. So you will be applying really significantly less water to your trees. So you have to factor in the system losses and then increase your water applications by that factor. Okay. So typically in California, flood and furrow irrigated orchards, we have 35 to 40% of water being lost in deep percolation and other wastage. So you have to apply at least 35 to 40% more water in order to meet the tree demands. So I don't think I need to go over this, calculating number of trees per hectare. You can figure this out. This is a really, and you have the copy of this presentations as well, I believe. So you calculate your number of trees per hectare. Then you have, web resources like Meteor Blue that gives you the evapotranspiration, reference evapotranspiration data. So you get the reference evapotranspiration data and you get the average evapotranspiration, reference evapotranspiration data. Getting to this equation, some of the slides we already had done in Georgian, so that might help you. How to calculate the water needs? Evapotranspiration of the crop is based on two factors. The reference evapotranspiration that you get from your web resources, your weather station for your particular region or site. And then there is crop coefficient for the almonds that you will use. And we have a table of crop coefficients for almonds that I got from the FAO studies and also studies done in California. It could vary region-wise, but you can use the FAO numbers done in Europe, or you can actually take some guidance from the California research numbers. Okay, so the crop coefficient is basically particular to a particular crop. So almonds will have one chart for crop coefficient throughout the year. So you multiply that crop coefficient with the reference evapotranspiration and get your evapotranspiration for your crop. That is the basic evapotranspiration calculations without factoring in anything like system uniformity or efficiency. Okay. So once you have that evapotranspiration for your crop, now you basically need to factor in the irrigation efficiency. So basically, if you have 95% efficiency, so you divide evapotranspiration of your crop, ETC, by 0.95, and that number will be the amount of water that you would need to apply. You need to know your soil's water holding capacity in the next step, because now you came up with a number that is the amount of water that I need to apply to my trees. How to schedule that water over several days. So if you, for example, if you want to apply half megaliter this week per hectare. So how do you distribute that half megaliter? Can you apply that half megaliter just one day and the rest of the 6 days of the week you don't irrigate anything? That will not be a good scenario, because what if your soil is sandy and all the water that you apply at once percolates down below the root zone, much of that water, and the rest of the 6 days you will have deficit. So the water holding capacity of the soil really comes in at an important step here, where you need to know how to stagger your irrigation application, how much water you can apply at any given time. So based on all these factors, you can basically calculate how much water you're going to apply every day or in every irrigation set. Okay, so basically there are only just three components: irrigation frequency. Irrigation frequency is basically what we need to determine in a drip or micro sprinkler irrigation scenario. Based on your soil's type, you can decide that, okay, I want to apply irrigation every 3 days. Okay, then based on the water holding capacity and based on previous year's irrigation applications, you can have an idea of how much water your soil can hold for every day of irrigation application. So you can start with that number by roughly having that idea. Then you can determine your crop evapotranspiration, and then you can calculate your amount of irrigation water to apply, and then make sure that you do not, you do not go over your applied water based on your soil type on a particular day. Okay. So typically in California, the drip irrigation during the peak summer months, they are run daily. Sometimes they are run every other day, depending on your pump's health and your water availability. So in micro sprinkler, sometimes you skip 2 days or 3 days. So this is a basic calculation. I would go into the calculation here. So you make a chart for a day, and you get the evapotranspiration from the weather station. This is a reference evapotranspiration, multiplied by the KC for that particular month, the crop coefficient, and you get ETC. Okay. So once you get that, then you factor in the system efficiency. If you have drip irrigation system, if you have efficiency of 90%, you divide that factor, you divide this equation by that factor, and you come up with the actual water needs. I calculated in inches per day, but you can easily convert it to megaliters or 1,000 liters. Okay. This is the average water holding capacity, the chart to guide you on how much water every foot of your soil can hold. I just converted this to mm per foot of the soil profile. Very coarse sandy soils can hold 15 to 25 millimeters for every foot of the soil. And fine clay soils can hold much more water than that, at least 3 to 4 times that water. So this gives you an idea of how much water you can apply at any given time. And we usually apply water for 3 to 4 feet of the root zone, because the almond roots go typically down to 3 or 4 feet. Okay, so the next thing is just calculating the runtime. I have this calculation in gallons, but we can actually work out this in mm or megaliters easily. Okay, so now one more factor to keep in mind is when you are going to start your irrigation, once you have the field to field capacity, you have a lot of water in the soil. Think of your soil like a sponge. When you fill the sponge with water, a lot of water actually goes down with the gravity and goes out of the sponge. Whatever water remains in the sponge after all the water has been drained through gravity, that is what we call field capacity. Same is true for the soil. You fill the soil profile fully with water and then let the water drain with gravity. And after all the water has been drained with gravity, whatever water your soil is holding at its maximum capacity, that is field capacity. So from the field capacity, you can your trees can start drinking water drop by drop every day. And then if you do not apply any irrigation, there will be a time where there will be no water in the soil profile, the only water in the soil profile will be really tightly held in the soil pores. That will be the wilting point, where your trees are so much stressed that it cannot come back from that stress. We do not recommend to go all the way to that. The available water between the field capacity and wilting point is the water that is available in the soil. We only recommend that we can use only half of that. Okay, so basically total available water times 50%. So whatever total available water is in your particular soil, you can only use up to 50% of that. You don't use beyond 50% of that water. So you only use 50% of that available water and then apply more irrigation. Okay, so this idea helps you when you have your soil moisture monitoring sensors and you know how much water you have left in the soil profile before you can decide to turn the irrigation on. So this is again the soil available water content of different soil types. So this is a relatively simple method in a flood irrigation system. In a flood irrigation scenario, we know through evapotranspiration, the same procedure that I explained to you before, whatever water your trees end up using, including the losses to atmosphere, basically the total evapotranspiration demand. And then, you add up the daily values of your water use and then bring this total for a period of days that your trees are using. So for example, this is calculated on a 3-day period. So in this example, the first 3 days use 0.55 inches, and then the next 3 days, and so on for 21 days. So this is calculated for 3 weeks. So this orchard is flood irrigated orchard. It actually over 3 weeks, it uses 4.2 inches of water. Okay, which is basically 0.3, 1/3 of a megaliter. Okay, so per acre, that is per acre. So now all you have to do is think of your flood irrigation system applying this much water. If you are applying after 3 weeks, you know that this is the minimum that your trees need. So you factor in the losses. So you apply this much water plus any water losses that your system allows. So you apply that much water through the flood irrigation system. In the flood irrigation system, it's a simpler calculation, but now we have drip or sprinkler irrigation in most of the orchards. So we go through all those calculations. Again, to emphasize, in the field, a value of 50% is assumed to be the maximum allowable depletion. So we do not deplete all soil available water, but only go up to 50% to the as the maximum allowable depletion. Okay, so we'll come back to the technology later after we have the question and answer session, because I want to go to the irrigation system, irrigation strategies. So I will actually skip this for now. Okay. Before we go to the irrigation strategies, though, I would need to ask if you have any questions, or we can break for questions.
Yes, but I think it will be more perfect to ask the questions in the end of the session.
In the end of the session, okay, after everything. Okay, perfect.
Yes, as you wish. It's up
okay,
to you.
Sure, definitely.
Thank you. Thank you.
Definitely. Okay. All right. So before we go to the details of the irrigation strategies, let me just show you the supplemental slides, because we talked about these things quite a bit. The proper irrigation system design is, okay, so we have to have a proper irrigation system design in order to have a highly efficient irrigation scheduling or highly efficient irrigation system. So the accuracy of the system is really important. Whatever system you decide to install, it has to go well with your soil type, the crop you're planting, the orchard design. So there are a lot of different systems to choose from: drip irrigation, single or double line, or micro sprinkler, or sometimes you have dual system. What is important in accuracy is proper selection and sizing of components and the correct installation. There are a lot of different calculations, and I'm sure there is a lot of help from the industry. There are good irrigation companies working in Georgia, and they have the in-depth knowledge of the irrigation system design. So that is the first thing to get started when you are planting new orchard or establishing new orchard. The sizing of the components, the system pressure losses can be really great if you don't pay attention to the length of the pipes with a particular diameter. So you have to keep the pressure, system pressure, high enough to be able to achieve good distribution uniformity. Okay, so your irrigation system design company will tell you all about these things. Then your system has to be flexible for the range of operating conditions, for the pressure and the output, both components. Because the system may be operated under different conditions throughout the year. Water needs of the immature trees, young trees are small and increase with time. We have already seen that. Blocks at different elevations could get different amounts of water depending on your system design, and also distances. So I already talked about the distances and need to keep the pressure same over longer distances. So your sizing of your main and sub mains will vary. There are obviously soil differences. So you need to check your soil. How variable is your soil across your field? And if it's possible, you can design different types of irrigation system for your different blocks or for your different soil types. That really helps. Here in California, we tend to study the soil profile differences across the field well before we decide on planting or we decide on irrigation system installation. And sometimes we can actually create different zones for water application. So we have different system designs. And then, check your irrigation distribution uniformity and improve it. It's really important to work on your irrigation distribution uniformity for different systems, drip system, micro sprinkler, and the flood irrigation systems. There are different methods to check irrigation distribution uniformity. For example, in flood irrigation, the distribution uniformity is basically as a percentage from like a low quarter infiltration, basically the part of the field where your water infiltration is slow, and divide that factor by the average field infiltration across the whole field. Infiltration is basically the rate of water going down, moving down in the soil profile. So you divide those two, divide low quarter infiltration with the average field infiltration, and you get your distribution uniformity. Now, distribution uniformity can be affected by so many factors. In Georgia, I have seen a lot of orchards planted in topography where there's rolling topography. uneven ground on the hillsides, on the top of the hills. So, and I have seen, and I reflected that in the report from last year, that a lot of those places had non-pressure compensating emitters. So if you install the emitters which are not pressure compensating in a rolling topography, your distribution uniformity can vary by a lot. Obviously, the trees up in the higher elevations will get a lot less water, and that can affect your tree health. Again, to emphasize more on this thing, piping, the main lines, materials, and sizes, to maintain pressure in the system over long distances, that is really a critical component of the distribution uniformity. And then the filtration system and backflush, all of those affect the distribution uniformity. Just as a scenario here, I have two pictures, just giving you an idea of irrigation uniformity versus irrigation efficiency. Okay, so these are two terms we use, and sometimes they can be misinterpreted, or they can be misunderstood or confused. So irrigation distribution uniformity is different than the irrigation efficiency. Okay, so irrigation efficiency is basically, it's just a calculation of how much water you are applying through your system and how much water is actually getting to your trees. So the system losses, that is the irrigation efficiency. Okay, irrigation distribution uniformity is basically a calculation or estimation of how that water is applied in your orchard uniformly. Some areas might get more water, some areas might get less water. In a sprinkler irrigation scenario, you can easily see from a distance. You can actually stand in the middle of the row and look down your rows when you're irrigating, and those circles that your sprinklers make, if your circles are big and small and the size is varying, that means you don't have good irrigation distribution uniformity. And in a high wind scenario with a sprinkler irrigation system, that can really be a problem. So based on your site conditions, for example, if you're in a really high windy condition, if you're in a really sandy soil, based on your soil and environmental conditions, choosing the best system for you is really, really critical. So let me go back to the other slides. Excuse me. Okay. So the irrigation strategies. Now we are done with knowing the basics of irrigation scheduling on how to calculate water. And a good part of that is also that I can walk you through the calculations. Some of you who are new to these sessions, we will definitely need to work on those numbers again. Okay, so we'll work that out in the question answer session. What I mean by irrigation strategies, it's not always true that we get a lot of water that we need and we don't need to pay attention. Most of the times we need to actually think ahead of how much water we have available and how much water we can, how best we can use that water. I have seen in many places in Georgia, some of the places we don't have issues of water availability, but in some other places we have a problem where you don't have water available through the critical conditions, through the critical phases of the plant growth and development. And then there are scenarios where you have water available, but it's not good quality water. It is high in salts, the soil pH is high. So how to use that water in a really wise manner so that your water gets to your trees. Excuse me. So if you have dry weather, it can cause issues like salinity issues could increase multiple times if the salt levels in your soil are high. Okay. So if you have a lot of water in a flood irrigation scenario, and you have salts in your soil, you would probably be safe because your flood irrigation will push those salts down below the root zone into the soil profile, into the underground water aquifers. But if you have salinity issues in your soil and you have just enough water applied through drip or sprinkler irrigation system, then your salinity issues are going to be a problem. So water quality is also another problem. If you have a really good soil, but your water is not good quality, if your water is high pH, and if your water contains salts, eventually your soil is going to be salty because you are applying that water week in, week out. So your soil becomes just like your water over the years. So you need to pay attention to your water quality. Crop load and nut quality, drier weather, lack of water, and really hot, very less humid conditions, they can affect your trees' growth. They can affect your vegetative growth of your trees because dry weather, high winds, hot temperatures, and low relative humidity increases water stress, and that can affect photosynthesis. And when photosynthesis is affected, your vegetative growth is going to be low. And a little bit of water stress can actually decrease your crop, and also decreases nut quality. Water stress during different stages of growth in almonds can actually create different kinds of nut quality issues. We'll go to that in this presentation. To get a maximum crop with whatever water you have, excuse me. Number one important thing is to irrigate accurately. That is the most important thing, okay? And it's true in every scenario, not just when you have less water. If you have good amount of water, even then irrigating accurately is the most important thing, because you cannot just keep applying excessive water. I always tell my students, and I always tell whenever I speak to a group of farmers, the almonds, and in Georgia, all of the growers, they are well aware of that the almonds are a crop of the desert climates. The almonds originated in the Middle Eastern regions, west of India, in regions like Iran, Iraq. They thrived through the ages. So the almonds are genetically, they can withstand a little bit of drought stress, particularly mild to moderate water stress. However, when you apply more water to those trees, they really show symptoms of overwatering really quickly. So applying more water than needed continuously to the almond crop, it actually affects the tree health really negatively. So what we recommend is we use monitoring devices like soil moisture sensors. We recommend that you use the evapotranspiration method for scheduling the irrigation. And then we recommend using equipment like pressure chamber wherever needed. You don't need a pressure chamber in every situation, but there are some scenarios where your trees are dying because of overwatering. If your trees have fungal issues because of overwatering, then we recommend that you fine-tune your irrigation applications by using pressure chamber. Okay, we will talk about pressure chamber. I have the slides about pressure chamber that can really help in problem areas. Another thing is to know the phenological stage where you can reduce watering. Phenological stage is basically the stage of development. Phenology is the developmental stages of any crop, which means that at bloom time, you need to irrigate differently than when it's leaf out. In summer, when the crop is developing, when the tree is bearing nuts, when the shoots are growing at a really high rate, you need to irrigate differently. And then in post-harvest, when the crop is gone, you need to irrigate differently. So you need to know your different stages of growth and development for your crop and identify the stages that you can actually reduce the watering if you want to, or if you don't have enough water, identify those stages that you can actually apply less water without having much effect on the yield. And then irrigate knowing your soil's water holding capacity. I always lay stress on this. Excuse me. Whenever you have an orchard, the very first thing, if I buy an orchard already planted, or if I'm starting an orchard, the first thing that I need to do is to know what's in your soil, what type your soil is, how deep is the soil profile, what are different layers of different kinds. We here, when we plant the orchard, we dig a lot of holes in the soil with the backhoe. We usually go up to like 6 feet. Even when the roots of the almonds only go to 4 feet, we dig the soil up to 6 feet with backhoe just to look at the soil profile. There are cases where you have different layers. You have sandy layer, you have a clay layer, and you have water percolation problems. So you need to know your soil type. You need to know the layering in your soil profile. And from there, you need to know your soil's water holding capacity. Principles of irrigation efficiency. If you follow these principles, you can have really good, efficient irrigation system and good, efficient irrigation scheduling or irrigation application. The first one is the system efficiency. Today, we put a lot of stress on the system. Your system efficiency will dictate a lot of things for the irrigation efficiency. The second one is using evapotranspiration data. When you use evapotranspiration data, then you know that your trees are needing this much water every day. So you can actually easily calculate the accurate amount of water that you need to apply. Excuse me. Then, of course, your soil's water holding capacity is one of the components of irrigation efficiency, achieving full irrigation efficiency. Knowing when to irrigate. Soil moisture sensors give you a lot of information on knowing when to irrigate. If you want to really fine-tune your knowledge of tree water stress, you can use tools like pressure chamber. And then irrigation uniformity, that is the irrigation distribution uniformity that we talked about. If you improve your system's irrigation distribution uniformity across your orchard, that will help you increase the irrigation efficiency. So if you stick to these principles, you can have a really good irrigation application efficiency. Excuse me. Okay, so this is a slide from the work of Dr. Bruce Lampinen at UC Davis. we have on this, on the y-axis, we have the cumulative applied or calculated water in case of in inches of water. We can do a quick calculation in megaliters. So basically the evapotranspiration for this orchard in 2014, went to basically 40 inches, okay, which is about 0.9 megaliters. Oh, sorry, not 0.9. Oh, 9 megaliters of water, about 8 or 9 megaliters. Okay. So what these researchers did, that how over the season the water use adds up, and the cumulative water, the evapotranspiration was about 40 inches, which is about 9 megaliters. And this is a grower applied irrigation. The grower was meeting the full evapotranspiration demand almost very closely. And then when they applied irrigation, 1 bar below, 2 bars, 4 bars, 3 or 4 bars below the actual baseline, and then you see the consumptive water use, the total water use reduced to early 20s if you continuously applied this much water. Okay. So what this did, this is an almond production function study again. Yeah, if you decrease the application of water on a per acre basis compared to the full water demand, excuse me. So this is the plot yield in tons per acre. The grower applied 100% of almost close to the evapotranspiration, full evapotranspiration. 1 bars below evapotranspiration was basically what the grower applied. 2 bars below was 93% of the grower, and 4 bars below was 91% of the grower. Okay, so the yield did not, this was not significant. Okay, however, you can see the significant reduction in the tree nut weight as you go lower in percentage of water application. Okay, so the power values, we did not go into the photosynthetically active radiation, the canopy light interception concept in this presentation. Okay, so the power values actually increased when you applied a little bit less amount of water. Okay, so the plot yield per unit of power is in the lowest irrigation, it is about 88% of the grower's power value. In 2015, second year of continuously applying less water, now you started seeing significant reduction in the yield in the lowest irrigation. Okay, but here, if you even go up to 3 bars below, your differences were not statistically significant. Okay, and then there of this treatment, same thing happens. If you continuously stay 4 bars below, which means if you are continuously applying 85 to 90% of your tree demand every single irrigation, then you are going to have significant yield losses. However, if you stay around 95, 96% of your full tree water demand, excuse me, you actually do not lose any yield. In fact, you basically increase your water use efficiency because you're applying less water and you're not losing much yield, or even nut quality. Okay. So that is the water production, almond water production study from 2014 through 2016. We talked about almond phenology. This is based on the non-perennial cultivar, the dates for the European cultivars that you have in Georgia, they will vary. The timeline between bloom and leaf fall or post-harvest will vary, but the succession of these things happening over the season is the same. Okay. Excuse me. So in the beginning of the season, right after the dormant season, we have bloom in almonds, and then that is followed by a period of shoot expansion and fruit development. Right after bloom, when the nut set happens, we have a rapid shoot expansion after leaf out, and then the rapid fruit development stage. When summer approaches, we have the kernel development almost complete. In Californian conditions, we have that around June. I have seen in Georgian conditions, that is the kernel development is complete somewhere around late June to early July, when the kernel is no longer milky and the kernel is starting to solidify and dry weight accumulation. So that phase is followed by hull split. Hull split is a critical stage in almonds that indicates the process of maturity for the almond nuts. And after hull split, a few weeks after hull split, when most of the nuts on the tree are splitting the hulls, then comes the harvesting. And around that stage, when the nuts are mature on the tree, the trees have flower bud differentiation starting for the next season. So that's a really critical point. The almond trees bear flowers on the buds which were set the previous year. Okay, so now the almonds are going to bloom. In California, they're going to bloom next month. In Georgia, they're going to bloom in 2 months. Those flowers will be becoming flowers on the buds, those buds were set last year. And in the cultivars that we work here in California, the bud set or the bud differentiation period is right around the harvest time in California. So that is really critical, because if we actually decrease amount of water applied to the trees during that phase, the buds will not set properly for the next year. And then the leaf fall we have in November, and the period, dormant period goes from November through February. In California, there are scenarios where we don't have enough water by the time we harvest. So some of the growers had to cut back or completely cut water after harvest. They did not apply any water after harvesting. That did 10% reduction in fruit set, according to a university study. 10% reduction in fruit set the next year, 33% reduction in the fruit load in the next year, and 43% reduction in yield when you actually compound these two factors. When you have reduced fruit load in the first place, and reduced fruit set to begin with. So that's the reason we do not recommend cutting off water in the post-harvest period, because the almond trees are shaken by the machines and they stay on the ground. So during the period that the trees are harvested, we have to stop irrigation for at least a week or 2 weeks, depending on the irrigation system. So when your trees are not getting enough water for those 2 weeks for the harvest period, then you have to actually apply at least some amount of water once you pick the nuts from the ground. Excuse me. Okay, so the first and foremost thing, irrigating during the nut developmental stage is critical. The nut development starts right after nut set. Whatever variety you're growing, you will have a nut set time in the spring, and all through hull split, that is the nut development period. Irrigating during that period is really, really critical, because after the nut set, the sizing is developing, the nut size is increasing, and the kernel is filling. So at that time, watering is really critical. So we need to track the nut development during the season. One thing that you can always do is when you're walking through your field, you can actually cut the nuts. You can take a knife and cut the nuts and look at the kernel development, how the kernel size is increasing, and how it's developing. Enough soil moisture is needed during the bloom time. That is usually done by the winter rains. Here in California, we usually get a lot of rains in winters. Some years we get no rains, so that's a drought year. The point is that when your trees are going to bloom, a few weeks before bloom, you need to make sure that the soil moisture, you have enough soil moisture. If it did not rain for some reason and your soil is dry, sometimes you have to turn your irrigation on before bloom just to maintain soil moisture. Excuse me. One another reason to actually apply soil moisture, to actually apply water before bloom, is that the almond trees actually develop their root system before the bloom. The first root flush happens right before bloom. Okay, so if the trees don't have enough moisture in the root zone, it can actually lead to poor root growth and poor root development. So that's an important factor. Okay, so you have to have enough soil moisture during the bloom time. Then after the nut set happens and during the nut size progression, irrigation is critical, particularly because the nut size is increasing. So there is a lot of water demand. If you reduce the water during the nut sizing, it can reduce the nut size significantly. Usually the first irrigation of the season is hard to schedule. So we talked about irrigation scheduling in the previous slides. And the first irrigation is one of the most difficult pieces of this whole picture. Okay, that is because in California we have a situation where we don't have enough water usually every year. So we need to think about the strategies that we can delay first irrigation. Okay, so how can you delay first irrigation? You can keep checking your soil moisture. And in California, for example, we have bloom in February. We have bloom in mid-February. The nut set happens during right after bloom during the first week of March, and then starts the rapid nut size development period. However, in California, we do not start irrigating until mid-April or even the end of April. That is because we have enough soil moisture from the winter rains in a normal year, in a normal rain year. So what is really critical is that you keep on monitoring your soil moisture levels. You keep on monitoring your soil moisture levels, and doing that, you can actually avoid over irrigation. The common mistake that a lot of people make, because they think they have enough water, they don't have a water problem, so they start irrigating early on without checking soil moisture. because when the spring season starts, when the temperatures start warming up, they think that, okay, we need to start irrigating. That actually leads to over irrigating. Okay, so most of the growers who have enough water, who have plenty of water, they typically start the first irrigation of the season too early. And that I have seen that creating a lot of problems in a few weeks. Okay, so if you have probably seen in May or June during the period when the almond kernel is still milky and your almond trees are showing some yellowness, leaf yellowing in the middle of the canopy, that is probably because the grower started irrigating too soon and there was already good amount of moisture in the soil, but they still started irrigating, and the trees actually started getting more water than they needed. So those are usually the signs of over irrigating, and that leads to the issues. We will talk about over irrigation in a few minutes. So by scheduling your first irrigation really carefully, you can not only save on the amount of water that you need to apply throughout the season, but you can also improve your tree health. Okay, next one. Excuse me. So on the other side, if we have water stress during the early fruit growth stages, it can lead to smaller fruit. Because the period from the nut set through full maturity, it takes a couple of weeks, and water stress during those periods makes a smaller fruit. It can also increase stick tights. Stick tights are the nuts that actually stay on the trees even after shaking. They don't come off easily, and that's usually a sign of water stress. It can also increase hull tights. Again, hull split is a physiological stage, physiological process. And when the trees are irrigated properly and the nuts attain full maturity, the hull starts splitting. Wherever we have water stress, we did not apply enough water during the early fruit growth stages, we do not have hull split. So the hull tights are basically the nuts that still have a tight hull on them, did not split, and that's a problem. That's a nut quality issue. Severe amounts of water stress during the early stages can lead to fruit abscission or fruit drop. Where we have drought scenarios, we see a lot of fruit drop happening during the April, May, early fruit development stage. And that happens because of two reasons. And one of them is basically low photosynthesis, low amount of photosynthesis, because the tree needs to feed the developing crop. And during the periods of early fruit development, rapid fruit size attainment, and kernel development, there's a lot of carbohydrate demand. If your trees are low on water, then the photosynthesis is not to the full efficiency, and a lot of nuts cannot get enough carbohydrates. So the developing nuts, after the nut set, they compete for carbohydrates. So if the supply is low, if there is not enough water, the leaves are not making enough food, a lot of nuts would drop. This is growth stages chart for almonds. So this is based on the California cultivars. The months go from March to September. We divide a typical growth curve for the almond nuts is divided into 3 stages: stage 1, stage 2, and stage 3. And stage 1 is the stage that we were talking about just in the previous slide. That is the stage of size attainment. And that starts right after nut set. Okay, so these three lines, they represent the first top one is the outside hull dimension, the total nut size or the length. The middle one here, that refers to the seed, which is the kernel. And this one is the endosperm. The third one is the endosperm. And the next one is the embryo. And the last dotted line is embryo dry weight. So in normal orchard conditions, we only pay attention to these two. Okay, so the first one, the overall nut size, and then the second one, basically the kernel size. And they go really parallelly to each other. Okay, so the first 2 months of the nut growth, the stage one, are really rapid, and the length increases at a really fast rate. If you apply less water in this period, the nut size will decrease, and that is definitely going to affect your yield. When the next stage starts, that is the stage two, which is growth in size of the embryo. When the embryo starts increasing in size, and that happens during the month of May in California. Severe deficit in this period, it will increase shriveled nuts. Sometimes you may have seen that the kernels have shrivels in them. That is because you did not apply enough water through this period. And then there's a period around hull split. Can we please request the participants to mute their mics? Oh, okay. Sorry about that. There was some background noise. Okay. So the next stage comes the stage around the hull split, where the nut size has been attained fully, the kernel development has completed, and the trees are ready for hull split. Okay, the maturity is being attained. So the researchers have found that you can actually apply a little bit less water during that stage. And that is basically the regulated deficit irrigation that we call it. So that is through, during the month of June, where you already have your embryo size and the nut size completed, and now the nut is going towards maturity and the final stage of the dry weight attainment. Okay, so that is a window in time in the growth and development stages of almonds that you can actually apply some water stress or reduce the irrigation. Right after that, when it is really close to harvesting, and that is the stage that the dry weight accumulation happens. If you do not resume full irrigation, if you continue water stressed, then again the kernel develops texturing, increases the kernel weight. Okay. Right around harvest time, when I mentioned that the buds for the next year are set, that will affect the bud set for next. If you apply some water stress, or if you're irrigating less than normal during this period, then the crop for next year and the yield for next year will be affected. So, and then post-harvest, we do not have this in this slide. Later in the post-harvest, when you're actually going to fall and the leaf fall, And in Georgian conditions, because the late maturing varieties, the period between harvesting and the period between the dormancy is really small. In California, the period between harvesting of most of the varieties, period from harvesting all the way to dormancy, we have at least 3 months time. In Georgia, we do not have for most of the maturing varieties. So during that period, you really need to monitor your soil moisture. At least once you have to irrigate after you shake your trees, after you harvest your trees. You have to apply a good amount of irrigation at least once, and then monitor your soil moisture. If your evapotranspiration demands start on decreasing quickly going into October and the leaf fall, then you can basically cut off water for the season and let the trees go dormant. So it really depends on your orchard condition. It really depends on your timeline for your variety when it matures and when it is harvested. But this is the basic guideline through the nut development stages. Here is another irrigation strategies or production function in almonds done by the university. Here there were 3 scenarios. One, the blue line was full irrigation throughout the season. The red, the peach colored line is the regulated deficit irrigation, which means that the trees were irrigated at full water demand throughout the first, throughout the period that the kernel development was complete. So after the kernel development period, we basically stressed the trees and applied less amount of water. The gray line is the drought scenario where you only applied 75% of the total evapotranspiration demand throughout the season. Okay, so right after nut set, when we were to start the first irrigation in April, from the very first irrigation, we only applied 75% water throughout. So you can see the yield differences. Okay, this is the percentage of kernel weight that translates into yield. Between first and second strategy, the regulated deficit irrigation and the full irrigation, the gap is really small. Okay, and I believe from this study it was not statistically significant. Okay, so this gap is really small as compared to this gap with the full irrigation versus the application at only 75% of evapotranspiration. So the take-home message from this chart is that if you have less amount of water and then you apply reduced water starting around the stage of hull split throughout the rest of the season, you're not losing much on yield. But if you don't have enough water throughout the season, you can still apply 75% of water across the season and then have somewhat yield that will be less than the full yield potential. Okay, so another scenario that you could do is basically apply the reduced amount of water right around here, right before hull split, and then for a couple of weeks you do not apply water, or you apply less water, or reduce 25 to 50% water, and then apply 100% water after hull split, and that will be even closely matching the full yield potential. So the idea is that if you want to save on water, you can save on some water during the hull split. And it's not just about saving water. It is also to decrease issues like hull rot. And I have a slide talking about that. So this is the almond regulated deficit irrigation. Again, another slide from last year's that, when we discussed this in the training. Regulated deficit irrigation, leaf out to nut growth, there is no potential. From mid-June to hull split, yes, we can reduce 50% irrigation up to 50% without any issues. At hull split, going forward, we don't want to deficit irrigate because we already irrigated less right before hull split. And then in the post-harvest, it depends on your variety. It depends on your season. So you may be able to apply less irrigation in the post-harvest. Okay, so here is the scenarios when regulated deficit irrigation was applied. It actually increased the hull split speed. It hastens the hull split. So in the regulated deficit irrigation scenario, the hull split approached sooner across the canopy. So there was more uniformity in the hulls splitting. It also reduces hull rot. Hull rot is a disease that is caused by common fungi. One of them is bread mold, rhizopus. Another one is monidania. And then there is a new fungi, a new fungus in Aspergillus genus that also causes rot of the splitting hulls, because at this stage, the inside of the hulls are really soft and the fungi attack. If there is a lot of moisture in the canopy, if there is a lot of moisture inside the tissue, then the fungi attacks and the hull starts rotting, which is a really severe, a serious nut quality issue. So this hull rot, the fungal diseases decrease if you deficit irrigate right before hull split. And it was found that there was no yield reduction. So in fact, you benefit from applying less water during hull split. Overall, in this study, it was found that we could use 13% less water, but you must provide water right after your hulls start splitting, so that you can resume your water demand for essential developmental functions. This is a drought spell scenario. Again, I think I presented this slide last year. So in this scenario, we had a severe drought. So in this orchard, water was completely cut off. Not completely cut off. I think it was only like 25% of the total, less than 25% of the total water demand throughout the season. So the yield really dropped next year because of poor bud set. And it took the orchard 2 years to come back to normal. Okay, switching gears, we need to talk a little bit about the water use efficiency of different almond rootstocks. Whatever we do in terms of proper irrigation scheduling or system design, we have to keep in mind that different rootstocks and different cultivars have different water use efficiency. They use water in different ways. So this was a study, a university study that compared these three types of rootstocks: bitter almond, plum rootstock, and peach almond hybrid rootstocks. And each of these rootstocks were irrigated at 90% of evapotranspiration, or 60%, or 30% of evapotranspiration. So if you compare all three types of rootstocks, in general, you can see that the peach almond hybrids, peach almond hybrid rootstocks had really high water use efficiency. So they were actually producing higher water, higher weight than the bitter almond and plum, particularly at 60% of water used. Okay, so if you compare this bar, 60% peach almond hybrid at 60% water application, it was higher, significantly higher than plum at 60% or bitter almond at 60%. If you apply only 30% water, which is a really dire scenario, and I don't think that you have those kind of scenarios in Georgia. At only 30% of water demand being met, the three types of rootstocks were not significantly different. But a little bit of reduction, some of the rootstocks can actually bear more efficiently a little bit of reduction in water than some other rootstocks. So this is a scenario where it was complicated by sodium and chloride. So the different rootstocks, planted with different cultivars. Top one is Bright's hybrid, and then Hanson. Both the varieties. Okay, let's talk a little bit more about the almond production function. How much water is absolute minimum that is needed to keep an almond tree surviving through the season? If you don't have any water, about 7.5 inch is the calculations done by university that you have to have so that the trees actually survive through the season. Okay. However, if you apply drastically low amounts of water, the biggest yield reduction occurs in the following year because of the poor bud set. The yield response is not linear as the water application increases, and we have talked about that. As you pass a critical point in water application, if you apply more water, your yields are going to start decreasing. So I have a collaborative trial in Australia, which we recently have this data in 2021 harvest in Australia. And that's the ultra high density trial. Ultra high density meaning that we had the planting distances, even row to row planting distances were shortened. So the highest density we had was 4.5 meter of row to row versus 2 meters tree to tree. Okay, so 1,100 trees per hectare, and this is the these are the third leaf trees of the Shasta and Vela cultivars, and this is the irrigation data. 9.7, around 9.7, 9.6 megaliters per hectare irrigation was applied. And you can see the kernel yield. This is in kilograms per tree. Per tree yields are usually lower in higher density plantings because you have 1,100 trees per hectare versus you have only 500 trees per hectare. So the trees yield more on a per tree basis in a low density orchard in comparison with the high density. However, in the third year trees, the tons per hectare was higher in high density. However, it was not statistically significant, but the tons per hectare was higher. And I can, what my perception for the next year is that that difference is going to be higher. So next year, we probably expected the high density treatments, we expect them to have higher tons per hectare. In case of Shasta variety, Shasta is a really vigorous tree. And in case of a vigorous variety, you can see that the trees planted farther apart, they grow really vigorously. So they had really, really high per tree yield, and that translated into higher tons per hectare. That is still not significantly different from the ultra high density, but over the next couple of years, I think I can expect it to be significant. So again, going with higher density or not, it depends on the cultivars that you are planting and the vigor of that cultivar. So the water use efficiency for all these trees at the 30-year data, they were not significant. So let's talk a little bit about effects of over irrigation. When the soil stays saturated over longer periods of time, the tree canopies look pale.
გამარჯობათ. ისმის ხმა თუ შეიძლება რომ დავასრულოთ და შემდგომ რომ დავსვათ კითხვები.
მე აზრი დაეკარგება, იმიტომ რომ აქ რაოდენობები იყო ისეთი მნიშვნელოვანი და რიგთა შორის მანძილები და ჰექტარზე ხეების რაოდენობა და
კარგით, მაშინ
კონკრეტული შეკითხვა და მე განვაგრძელოთ ის.
აქ ინტენსიურ ბაღებზეა საუბარი? ძალიან ახლო იყო ხეები დარგული და მაგაზე გვესაუბრება?
ინტენსიურ ბაღებზე იყო საუბარი და ტრადიციულზე.
და ჩვენთან ინტენსიური ბაღები თითქმის არ არის და ჩვენ შემთხვევაში როგორ იქნება მას? იქნება ეგეც აგვიხსნას რა. და მეორე შეკითხვა, კილოგრამები მოსავალი საჰექტარო რაც იყო ნაჩვენები, ეგ გულზეა, გატეხილ გულზე თუ გასატეხი მოსავალია? მადლობა.
Hello. Hi, everyone. Okay. So, can we continue?
Yep.
Sorry, but okay.
შეკითხვებზე რა უპასუხოთ? ორი შეკითხვა იყო.
All right. So, yeah, we have a last couple of slides, and then we can actually start the question and answer session in the last half an hour. Okay. All right. The over irrigation can have, in spring in California, we have seen that over irrigation happening when the growers just start applying irrigation and the trees are getting overwatered. We talked about that scenario. When over irrigation happens, the soil, the water fills, the soil pores, and the availability of oxygen is reduced, and the fine feeder roots are killed. Water and nutrient uptake is impaired. And during my visit to Georgia, I saw some scenarios where we had this kind of scenarios where you're probably having higher water applications and the trees showing poor health. Along with the over application, and the nutrient uptake is impaired because of the fine feeder roots being killed, and also because of the nutrients being leached below the soil profile. So the trees start showing nutrient deficiencies. So we have a lot of trees show yellowing typically in spring. And that is something that we always talk to growers about in mid-spring. If wet conditions prevail for prolonged periods of time, the crown rot can happen. Because of fungi like Phytophthora root rot happening. In spring, the temperatures start getting hot, and that further increases tree stress. Continuous wetness at the crown level can attract secondary pathogens like poria and Ganoderma and other secondary fungi that could actually weaken the crown area, and the trees start falling over. We have seen this problem in several orchards, that year after year, when there was the trees were overwatered, the crown, the base of the trunk got really weak, and the trees were falling over with a little bit of wind. So in high wind conditions in Georgia, that can even be more serious problem if you continuously keep on overwatering. They're more likely to fall over. So one thing to keep in mind, we already talked about this, scheduling the very first irrigation of the season very carefully is really critical because there is usually the stored soil moisture, so don't overwater. Starting first irrigation a little later than normal can be considered. In fact, in one of the studies in California, we actually delayed the first irrigation by 2 weeks and did not have any effect on the yield, but that was done carefully by monitoring the soil moisture. So looking at the soil moisture is the key thing. Why we need to avoid prolonged soil wetness? There are a lot of reasons to avoid overwatering. And one of them is that continuous flooding, continuous application of more water causes hypoxia, meaning causes lack of oxygen in the root system. And roots need oxygen to respire, to carry out respiration for their growth. Okay, so if the roots don't get enough oxygen, the roots will not breathe. Meaning that they will not create energy for their growth. So the root growth, once the root growth starts getting low or getting affected, then the overall tree health is reduced. Another thing is that once the oxygen drives out, ethylene, which is a stress hormone, the trees produce ethylene when there is more water in the roots, in the root zone. Okay, and ethylene can actually, because it's a stress hormone, it can actually stress your trees. The trees start defoliating and other negative impacts. Remember, the almond trees can survive some degree of water stress. So always irrigate only when the stem water potential is 2 or more bars below the baseline. Now I am talking in the terminology of a pressure chamber. We can go over that. Last year, I had planned to bring the pressure chamber, but I could not bring the pressure chamber during the flight. Hopefully, whenever I come to Georgia in person, now I have some pressure chambers that we can carry. So I would really want to talk to you guys about the benefits of using the pressure chamber. So hopefully that will work. But the point is always try not to match the full water demands. Just irrigate to a point which is a little bit lesser than than the fully saturated conditions. During the nut development stages, from mid to moderate levels of water stress is recommended for the almond trees, and that's how the trees would grow normally in a healthy way. If just low stress is maintained, the tree will potentially show symptoms of overwatering. That means that a low stress is not enough stress for almond trees. So we need to just stress them a little bit through the season. That is now still different from the drought conditions or severe stress. So that is the reason when I started with the first slide, I mentioned that we have to walk a fine line between giving too much stress versus giving too much water. So mild stress is always good for your almond trees. We went over the seasonal phenology. Ideally, we need to meet full orchard demand in terms of the evapotranspiration. However, full water during the hull split can cause diseases. We already went over this. And then if we have cover crops, that increases our water use by 30%. Water deficit in 1 year affects yield in the following year. That's another point that we are summarizing. And then some stages of the development are more sensitive to water stress. Stress during early season reduces size. We already went through the details. Stress can cause nut drop. During fruit, each one of the development stages, we already actually went over these. So this is just summarizing all the points. Okay. So I just added this point here that about a quarter of megaliter per hectare application just before hull split will improve hull split and reduce stick tights. That is based on the research done here in California. Post-harvest, we talked about bud differentiation and severe water stress during post-harvest can reduce next year's crop. Late maturing varieties, we talked about late maturing varieties. So this is basically summarizing all the points that we discussed. So this is 9 o'clock. I can stop here and get into the question and answer session. And then, the information that we could not present, I can present tomorrow in the next session. Okay. With that, I thank you all for your attendance, and I will take any questions.
Yes. Hello. Can I?
კითხვას დაუბრუნდეთ, რომელიც დასვა ბატონ არჩილ, მათ მე გავაგზავნოთ დანარჩენში.
ან ბატონი არჩილის შეკითხვით დავიწყოთ, ბატონ არჩილს მოდა და შემდგომ გავაგზავნოთ.
უკანო დაუბრუნდეთ ის რო იყო სუპერინტენსიურის სლაიდი რა. იმაზე იყო შეკითხვა შეჩერებული.
Was there a question for me?
Yes. Garrett, can you come back to the slide?
Yeah, here.
Yes.
Garrett?
Yes, this is the correct slide. Yes.
Yeah.
Slide.
So you have a question about this?
გავიმეორო კითხვა?
იგი გაიმეოროთ.
Yes.
აი ამ ცხრილში გაშენების ზომები რაც არის მოცემული, ეს არის როგორც ვთქვი ინტენსიური ბაღის ვარიაციები და ჩვენთან საქართველოში ინტენსიური ბაღები ძალიან პატარა რაოდენობით არის და უმრავლესობა არის ჩვეულებრივი კლასიკური ბაღები და იქნებ ამასთან დაკავშირებით მონაცემები გაგვიზიაროთ, ეს ერთი შეკითხვა. და აქ მოსავლის რაოდენობა კილოგრამი ხეზე რომ არის მოცემული, ეს გატეხილი თუ გაუტეხავი ნაყოფის შემთხვევაშია.
ვის არ აქვს
გადაუთარგმნის ვინმე კითხვას.
Okay.
So is there a question for me?
Garrett,
Yes.
okay,
Yes.
Garrett, can you switch the interpreter page? Just click on the interpreter.
Oh, interpretation?
Yes.
Yes. So the translator can translate you the question.
Oh, okay. Sorry about that. I did not have that on. Okay. Yeah. So I selected English there. So I cannot still hear anything.
I think it's better to switch to German.
Oh, okay.
German is a Georgian language.
Oh, right. Okay. Sorry. Okay. I did not know how it works. Sorry. Okay. Yes.
It's working now?
It's working? Garrett, you need to switch interpreter channel.
So, okay. So I have selected German.
I think you need to click English. Just clicking.
Now yeah, I can hear you now in English.
Okay,
Yeah.
the question was ultra high density trial slide, the one we have it.
Right.
Gesmis Garrett ჩვენი
It's me.
ანუ ისმის ხო? შეკითხვა ეხებოდა
The question is related to this particular slide on ultra high density. So this is hyper intensive. Could you please elaborate data and your experience on traditional ones, because we don't have ultra high density orchards in Georgia. And the second question, this yield, is it in shell or these kilograms?
This is kernel yield. Okay, so the yield is in the kernel yield, not in shell, it's the kernel.
So it's a kernel. And the second question? Conventional orchards, not high density.
Yeah, to elaborate, so the conventional orchard, in this, the treatment planting close to the conventional is 6.5 meters to 3 meters. That is the typical conventional system. And we still have, we have 500 trees per hectare. So that is the conventional system in one of the treatments here, okay? So every other one, so see, we have 4 treatments, the planting distances. So 6.5 meters row to row and 3 meters tree to tree, that is the conventional system. So you will see that each row that I'm highlighting here, this one in Vela and this one in Shasta, that is basically conventional. Does that answer the question?
That's right. Yes. Thank you. Understood. Can I ask 2 more questions?
Sure, please. Yeah.
You
talked about blooming and you brought example of Californian orchards. When is it blooming? Which month? And which cultivars? Are they early bloomers or late bloomers?
Okay, so in California, we have early, all the cultivars, if you compare to European cultivars, they will be early blooming in California. So our bloom time for the earliest blooming cultivar is mid-February, or sometimes around 10, 15 February or 19 February. That is the peak for the early cultivars. And the late blooming cultivars we have, first week of March. So that is the window for all the cultivars. I know that the European cultivars, and particularly in Georgia, they bloom, they even start, mid-March, right? So we are here a little bit early.
That's right, big difference, big difference. And one final question from me, megaliters, what are they in our system?
Oh, yeah, megaliters, basically I converted to megaliters because the metric system in Georgia, in Europe, and in Australia, we use megaliters. So in fact, a megaliter is 1 million liters.
Understood, thank you.
So I can translate a little bit more. I believe if you want to have like, for example, 1250 mm per acre per year, that will translate to about 12 megaliters, if that helps. Roughly around that.
1000 tonna თუ არ მეშლება
1000 tons megaliter. 1000 tons is a megaliter.
1000 tons, yeah.
So can I ask a question?
Yes, please.
First of all, on behalf of all the participants, I would like to thank you for such an interesting lecture. And now what's about the questions? How to measure the water quantity in the soil, and if you recommend any gadgets for that, any new technologies that have arrived in the technology market for us.
So, I think we need to work with the irrigation companies in Georgia, but here in California, we have the different types of soil moisture sensors, the dielectric sensors, tensiometers. So you can use the tensiometers. They're easy to install and use. There could be other soil moisture sensors that tell you the volumetric soil water measurements in your root zone. So typically the soil moisture sensors are used to quantify the volumetric water percentage in the soil. So yeah, that's the method that I would recommend.
Yes. Okay. Another question is about the drip lines. We are going to put the drip lines in the ground approximately from 20 to 25 centimeters in the depth and approximately 1.5 meters away from the tree. That's the reason, because we are trying to take away the herbicide using in our orchards, and we are going to use some technique that not to use any pesticides, herbicides in the orchard. What do you think about that, to put the drip lines in the ground?
Yeah, that's a good system. One of the things that and we here I have experience, and we grow a lot of organic orchards. So the biggest issue with the organic orchards is the weed control, and one of the good strategies is the buried drip. And you said how many centimeters? 20 to 25 centimeters?
Approximately, yes.
Yeah, so that is under not even 1 feet below the ground, right? We have one underground buried drip system on our university campus. So that's really great from weed control perspective. There are a couple of things that you need to monitor. If you have buried drip at that depth, I would recommend that you monitor your nutrient uptake or nutritional value in the leaves really closely, particularly potassium. Okay.
Yes.
So because now you are burying the water at 1 feet below the ground, and obviously through gravity, the water is going to go down. So that makes a little bit difference in leaching of the nutrients, particularly potassium. So I would strongly recommend you keep an eye on how your potassium moves in your soil. And plus a couple of other nutrients that can be leached down the ground, for example, nitrogen. So with that, I think you would be in great shape, because that's going to save you a lot of issues in weed control, also increases efficiency. And if you have issues like gophers or other voles under the ground, mouse, yes, those kind of stuff, you need to pay attention to that as well, because
yes, of
underground irrigation systems are difficult to repair and difficult to find the breakage.
Yes, and the last question is about the technology. Does the harvest technology play some role about the irrigation system? I mean, if we are going to use the shaker, in my situation, umbrella, what is the time before we have to stop irrigation system to make the hole open and make it easier to drop the nuts from the tree?
Okay. So when you are shaking with the umbrella, that makes it a little bit more easier. The only thing is that now if you have buried drip, you don't have the water applied on the surface, there is no issue of machines getting into the ground, right? All of those issues are solved. But based on California studies, we recommend that you stop, not stop irrigation, but we mentioned about the reducing the irrigation just before hull split to actually have the hulls split uniformly. But right after the hull split is progressing and going all the way to harvest, then the trees have to be irrigated properly. The only thing in California that keeps us from doing that is because we cannot keep irrigating the trees with the surface irrigation, particularly if we have sprinklers. We cannot keep on irrigating the trees close to harvesting because we have to bring the shakers in the ground in the field, and the machinery gets stuck if there is mud. So that was the reason for ground preparation, we have to stop irrigation. The other reason to reduce irrigation a little bit about a week before shaking is to prime, I would say, to prepare the roots and the tree for shaking. Because if you keep a high moisture level inside the tree when you are shaking, there is more chances of bark damage. So a little bit of reduced water about a week before shaking. Now it depends on your soil type. I mean, if your soil is heavier, right? So you have to estimate. So you cannot go by my numbers straight away, right? So you have to do some adjustments. But the idea is to basically reduce the amount of moisture in the root zone a little bit so that the bark of the tree hardens before you shake it, so that you don't get bark damage. So these are the considerations that you will do.
Okay, thank you very much again.
Thank you.
If I may I ask a question?
Yes, please.
Can you hear me?
Yes, I can hear you.
Thank you so much for the very prudent advice, many of them. I have a question. Newly built orchards from mid-December, during planting, it was well irrigated. When we have -2, -4 at nights in winter, do you recommend to continue irrigating? This orchard is in a windy region. Your comment on that?
So what kind of irrigation system they have? Do you have sprinklers or drip?
It's drip irrigation.
Okay. So, okay, in California, we use sprinkler irrigation for frost protection. So when it gets lower temperature, -1, -2, we turn the irrigation on so that we actually have a little bit of evaporative water getting into the canopy, and that helps protect the buds from the frost damage. Okay, so we do winter irrigation during those events when the temperature gets below 0, just to protect the buds from the frost. If you have a sprinkler irrigation system, that helps a lot because it creates more heat in the canopy when it's frost. But still, I have seen that if you have drip irrigation, you just wet the floor a little bit, that might help. Yeah, so yeah, from that perspective, I would say that you can try. From the soil moisture, the water needs perspective, I don't think that you have to consider other things like soil moisture.
Hello, may I be the next?
Yeah, sure.
Can you hear me?
Yes, I can hear you.
ცოტა გვიან შემოუერთდი ტრენინგს, მაგრამ ვერ
good morning to you and good evening to us. I was late in joining, but I did not listen on the nursery. Did you talk about nursery? What is the rootstock? Should we irrigate? Is there any formula or a guideline by cultivar when to irrigate and what should be the wetness in the soil and moisture? And do you plan to talk about this at future sessions? Thank you.
Okay, thank you for your question. So the irrigation scheduling that I approached and the way I explained and the way we have done work in California, so the demands obviously vary by rootstock and cultivar, but you have to actually calculate or look at the vigor of the tree, okay? For example, if you have a vigorous rootstock and a vigorous variety, the tree grows really tall and big, the canopy size is big, that is what going to affect your water demand for the orchard, okay? So overall, it comes to the percentage of shaded area of the ground, how much shade your trees are putting. So obviously different rootstocks, different varieties, different sizes of the tree will have different amount of shade on the ground. And that's what really dictates trees' water demand, okay? So it can be a lot of different rootstock variety combinations, but finally it comes down to the size of the canopy. And the bigger the size of the canopy, the higher will be the percentage of shade on a per hectare basis or per acre basis, and the higher will be the water demand. We can talk about that. I can explain that a little bit about that in the next coming sessions, but that is how we actually go by calculating the irrigation schedule, water demands.
Thank you so much. And the second question towards organizers, this video and presentations, shall we have access to that? I have another question. Yes, indeed, I'm the organizer. After the end of this presentation, we will share with you the slides and the recording as well. If you joined us late, it won't be a problem. You will get recording anyway. Thank you. I have a question. Can I ask a question? And
Sure.
which language?
In Georgia, we
As
have,
you wish.
we mostly irrigate with high pH river waters from 7 to 8 pH. Does it matters?
Can you I cannot clearly understand it. Can you repeat the question?
In Georgia, mostly we irrigate from rivers. So our river pH is 7 and 8, maybe like this. And does it matters?
Yes. So high pH, pH around 7. We have seen that in almonds, usually it's not a problem. Ideal pH is around 6.5 for good almond production. pH of 7, even 7.5, 7.6, we can manage with a little bit of soil amendments. A pH of 8 and beyond. I mentioned that if you irrigate your orchard with water of that high pH, eventually your soil is going to become like that in the root zone, unless you do some soil amendments or irrigation water treatment. So if you have high pH, we recommend some soil amendments, or we recommend treating irrigation water with some, acidic amendments.
Thank
So
you.
reducing the pH is important for several reasons, and one of them is micronutrient uptake. A lot of micronutrients actually taken up at low pH. So the trees can have a lot of different issues that show in the yield if you have consistently high pH.
Okay, thank you. I have several questions.
Okay.
So can we talk more about water demand and technology states? Maybe
okay.
in percents, or maybe I don't know how we can talk about it.
I mean, what you want to talk about in terms of phenology?
In which stage, how much percentage of whole year's water demand we can apply? Before bloom, after the stages, which stage and how much water? Maybe in percent.
Yeah, in percent, the almond production function studies that I quoted here, the latest one done in 2016, and then there's another study that was from 2005 for like 10-12 years. In terms of percentage, it depends the full water demand. However, most of the production function studies tell us that if you reduce the water by like 8 to 10% over the season, there is no effect on the yield. Now, when you mentioned phenology, like different stages, obviously different stages will have different effects. So it's usually recommended that you do not do any reduction at the nutset stage or the early development stage. Okay, if you do even 10% reduction at the nutset stage, the research has shown negative effects.
So one question I want to ask, please. I want to know before bloom in drought year, how we measure the moisture. With the pressure chamber, we can't measure because we don't have leaves.
Yeah.
So how we can measure the proper moisture before bloom after dry winter?
No, that's a really good question. So you cannot, measure with pressure chamber because we don't have leaves. And if you look at the evapotranspiration demand, because there is no leaves, there is not going to be significantly high evapotranspiration either, right? Having said that, because there are stems, and still we have some evapotranspiration. So the ET is not zero, even in winter months, okay? But it's really, really low. It's really minimal. So the point is that the trees are not taking up enough water, one, because they don't have leaves. Number two, because there is soil temperature is very less, the root activity is so low. So bottom line is that you just need to keep enough moisture in the soil, which we in California usually check with the auger, because at that time it's not critical, to use tools to monitor, stem water potential or anything, okay? Because we are just concerned about soil moisture at that time before bloom, because we are concerned about root growth. We are not concerned about stem water potential much, because the trees are not actively physiologically active in December. So the main point that I was trying to make is you can monitor the soil moisture with any soil moisture probe, or you can just do an auger and monitor soil moisture at depth. If you have a little bit of moisture, like, you can feel, and then you should be good. If you want to go into precision, you can still do stem water potential by getting the branches. We can do that, but the best way would be to follow the soil moisture probes, the soil moisture sensors, if you want to use technology.
Thank you. One question, and I'll finish. How can we determine soil's water holding capacity exactly, more or less?
Water holding capacity?
Yes.
So I think the best thing is to actually get your soil tested from a reliable lab.
Yes.
And that's the best way. Then, for that particular saturation percentage, you have the saturation percentage data, and from there on, the soil lab can guide you.
Our soil labs don't provide such an information. They only say the percentage of clay, silt, and sand. And can we determine this capacity from this percentage of?
Yes, so you will have to do a little bit of homework on that. I can bring in some more information on, if you have different components. The main idea that you can still develop is if you have an idea of the soil texture of your soil profile, how much percentage of sandy versus how much percentage of loamy or clay
we have.
Then you can actually go to literature and then have a range, develop a ballpark number, and you can actually start from there. Yeah. So, but
thank you.
Yeah. Okay.
Thank you very much.
კითხვა შეიძლება?
დიახ.
May I ask a question?
Yes, please.
Miss. მოგესალმებით, დიდი მადლობა.
Well, good morning to you, good evening to us. Thank you very much for this very interesting meeting. I have a lot of questions, but two are related to irrigation. I'll be quick. How many kilos of kernel on average by cultivars? How many kilos should be given by each tree, and what should be the price range for selling? Very general question, but still, let me ask this question. Thank you.
Yeah, that's a very good question. So I will have to convert to kilo, but let me give you the calculated answer to the best of my ability, because there's a lot of calculations in here. Typically, for the the standard cultivar here in California is non-pro. Okay, and the non-pro cultivar, the best yields in California is 4,000 pounds per acre. Okay, which, let me do some calculation here. 4,000 pounds is what is, let me pull up a Excel sheet. Divided by 2.2 is 1,500 kilograms per acre, times 2.47, so about 4,000, right? So that's the best yield, about 4,000 kilograms per hectare. That is the best yield of the best orchards for the non-pro cultivar. That's the kernel yield. Now, the kernel yield for the European cultivars is lower. Okay, so in an in-shell versus the kernel crack-out percentage in non-pro is about 60%, 60 to 65%, whereas in many European cultivars it's only about 30 to 35%. So the yield potential for the European cultivars, is less in in those terms. So if I have to account for that, everything else, keeping everything else the same, I would say that the full yield potential should be around 1,800 to 2,000. The best, if you want to match the best yields, so 1,800 to 2,000 kilograms per hectare would be the potential for a hypothetical scenario that we can work on. So that's as close to the estimation that I could go.
If I may, it will be much better if we have different structures of orchards. So if I could specify from one tree, not per hectare, one tree, very roughly, how many kilos, and what is the price range? What was the price range in the past? What is the price range at present, and what is the future? Thank you.
Oh, okay. All right. So let me do 23 pounds per. Okay. So
thanks so much.
Okay. So the typical yield that I was talking to you about, it translates to, in California, it translates to about 10 kilos per tree. Yeah. Right. So 150 trees give you 35 pounds, 23 pounds. Yeah. So it comes about 22 pounds per tree, full potential. It's about 10 kilograms per tree of the kernels, which the cultivars in your conditions might be lower. Okay, so that's what I was thinking, like per tree yield potential for the European cultivars would be around 5 to 6 kilograms per tree on a single tree basis. And the price, in the recent years in California, the price has been really high, and then it dropped because of the international trade. But the future scenario is now, over the past 10 years, we have been seeing the increase in California almond acreage, which is, in my opinion, is peaked already. In California, we can definitely not grow in acreage anymore. In fact, the California almond acreage is going to start getting lower as the old orchards are being uprooted, and there are places in California that can no longer grow almonds because of water shortages. Okay, so I'm not an economist, but based on my understanding of what's happening around me and what's happening worldwide, the demand of almonds is increasing, no doubt. The potential for planting more almonds is, I don't see that in California. So where do all those new almond plantings go? Places like Georgia or other places that can grow. So that tells me that we are in a good shape in terms of future potential, because California, we are pretty much peaked out and we're saturated. So in my opinion, the prices would stabilize and get better in the future. And to add to that point, in here the cutoff price is like $1.5 per pound for all the expenses, and of course there are a lot of different components that will be totally different in Georgia, but in California, if we get $1.6 per pound, we can cover the cost of production. Anything above $1.5 is profit. So that's the really broad figure or broad way of explaining it.
As for the prices, let me add that for the last 5 years, it's around $4 US and European almond. Prices are higher nowadays, like around 5. And good quality almond is in deficit.
Yeah, $5 per kilogram, right? €5, 4.8, according to today's caramel. Yeah, right. So, and this year in 2021, the Californian type varieties, they touched $3 per pound. $2.7, $2.8 per pound. So you can translate it to, it's about $7 per kg, $7 to $8 per kg. The prices jump back up for the California varieties. Yeah, so definitely the demand for good quality almonds is increasing.
I have a question.
Yes.
Can you hear me?
Yes.
If we control the moisture in the soil, what should be on average the moisture during irrigation during the year?
Okay. So are you talking about the soil moisture percentage?
Yeah.
So, different, it depends on the calibration of your soil moisture sensors, different percentages. I think, if I have to go by the soil moisture sensors in my university, depending on the soil type, we have, around 30-40% of soil moisture content in some areas, and then it depends on a lot of factors actually. So if I give you one answer, that might not be applicable to you. So it really depends on your soil type and the values that you're the type of your soil moisture sensor. So we actually go by inches here in California. So that's what we translate to mostly. Okay. So we apply like 1 inch of irrigation, and we follow it up if we have less than 1/4 of an inch water available, and then we apply more. So we go by inches. So I will have to do a little bit of calculation on that before I give you an answer, because I don't want to give you just a guesswork answer. Okay.
Okay.
Yeah.
Thank you.
I can find that out for you. Yeah.
Okay. Thank you.
A question, please. May I ask a question?
Yes, please.
Hi, Brad. Thank you very much for your insights, presentation. Very interesting. Actually, the irrigation is one of the crucial aspects, in my understanding, in a whole orchard development project. So that's why we all have some more questions. So my question is relating to the watering needs after the tree is planted. This is very important for our company, because we are going to plant trees by the end of this year in winter. And ideally we want to finish irrigation before we start plantation, but in case of any delay, we need to be ready. for the watering needs during after the tree is planted. So the general rule that we know is that the tree, although it's been planted in winter time, let's say January, February, it needs some watering after the tree is planted. So what's your suggestion about that? Do we need to apply watering once after the tree right away after the tree is planted, or we need to wait some time? Your general insight will be helpful.
Oh, okay, good. Thank you. That's an interesting question. Now, we have done what we do in California is when we plant, before we plant, we usually plant in winter months, and we want to make sure that we have just enough soil moisture. The soil is not too much muddy. The soil is worked out well. It has enough moisture in the ground so that you can bring your machinery, walk on it. Soil is not too dry. Once you have the proper conditions for planting, you plant the trees and immediately water the trees. By that time, we already have the irrigation system in place. If we don't have the irrigation system in place, we hose down. We bring a hose with a moving, water tank and apply a good amount of water to the newly planted trees. One that actually gives the tree enough moisture for the proper settlement of the roots. And also because when we plant the trees, we create a big hole in the ground and then we put some soft soil after it. So there are some air pockets inside. And those air pockets, when we actually plant and it's winter time, if those air pockets stay within the root zone and the soil temperature is low, that air can damage those roots, right? So we have to actually get delete those air pockets. So that's why we apply good amount of water to flush down more than the tree needs, in fact. So good amount of water right after planting so that you just take the air pockets out. You help the soil settle down around the roots and give the trees enough moisture for to reduce the transplanting shock. From then onwards, you only again go with the soil moisture, and after that, if you have good moisture, it's not spring pretty soon. If still winter, you plant in February, you have a good month before the temperatures start rising. I don't feel a need to water too much. Maybe a little bit of irrigation after 2 weeks, depending on your soil conditions. But I would really avoid overwatering because I have seen young trees being overwatered. Once after planting, definitely yes, lot of water. After that, just we just need enough water so that the trees don't get stressed for water, which is really hard. You cannot stress those really newly planted trees for water in late February or March, right? But the other side of the things is really critical. You can easily create a scenario where there is no oxygen and the newly planted trees actually suffer because of that. So try avoiding overwatering after you first watered them fully. I hope that helps.
Thank you very much. Yeah, absolutely. Thanks.
Friends, we need to say goodbye to Garrett at 10. So if you have any questions, feel free. But otherwise, let's say goodbye and then we'll continue tomorrow.
Yeah. Thank you. It's so late in Georgia. So have a good night and I will touch base with you tomorrow morning.
Do you
have any questions remaining? We still have time, a few minutes.
კარგით, მაშინ მოდი
Well, fair
დღეს
enough. Let's call it a
დავასრულოთ
day.
ჩვენი
This is the
ტრენინგი.
end of our
ხვალ
session
იმავე
today.
დროზე 7
Tomorrow,
საათზე
the same
დავიწყებთ,
time,
უკვე უნდა ვისაუბროთ
release the time to 7
ფერტიგაციაზე.
o'clock. We'll
დიდი
talk
მადლობა
about a
ბატონ
different
გარეტს,
topic.
ასეთ
Thank you,
საინტერესო
Garrett,
ტრენინგისთვის
for this
და დიდი
very
მადლობა თქვენ რომ
resourceful
გამონახეთ დრო.
presentation, and thank you for finding time to join us.
და ერთი თხოვნა მაქვს
Thank
კიდე,
you, and I have a
ბევრჯერ
request to
შეგაწუხეთ
you.
უკვე
I
რეგისტრაციის
have
ფორმების
asked
შესავსებად
you
და
many times to
ვიცი ერთი და იგივე
fill the
ინფორმაციას ვკითხულობ
registration
ხშირად,
form.
მაგრამ
I
მხოლოდ
know I'm
კიდევ
asking
ერთხელ
the same thing,
ჩავაგდებ
but could you
ლინკს და
please, I will
შემივსოთ ეს ფორმა
indicate a link
ხვალ
here. Could you
საღამომდე თუ
please
შეძლებ.
fill in by tomorrow evening, if you could? Thank you. We will. Thank you and goodbye.
დიდი මადლობა ყველას.
Thank you
და
and
შევხვდებით
goodbye.
ხვალ.
Thank you all. We'll see you tomorrow. Thank you. Thank you and goodbye. See you tomorrow.
All right, bye everyone. So I think I'll leave.
Goodbye, bro.
All right, bye.
Thank you. Thank you. It was early morning for you, and
It's always a
thanks for
pleasure.
your effort.
Yes, always a pleasure. Thank you. Bye. See you tomorrow.
Have a good day.